we are now going to discuss what friction is all about. Now, as we all know, friction is this force that acts on surfaces that can oppose motion. But we must understand that there are actually two types of friction. One of them is called static friction, and the other one is called dynamic, or some people call it kinetic friction. Yeah, let's just put both the names over there. Now, as the name suggests, static friction is basically the friction that acts on a static object. And so static friction actually opposes the tendency to move, So think of the last time you tried to move a heavy object like so. That's you trying to push it, and you realize that it's quite hard to get it to move. Yet, I can push it with a force of, let's say, 1 Newton. It doesn't move because the static friction is able to match that. So it'll just push back with a force of 1 Newton as well, which is the case, or rather, this is how static friction behaves. It will match you force by force for force, up to some maximum value. And this maximum value, Fs, is usually given by a coefficient μs multiplied by the normal contact force between the surfaces, or in this case, the box and the ground. Okay, and so μs is just known as the coefficient of static friction. It depends on the types of surfaces that are involved. And of course, it is unsurprising that this friction depends also on the strength of the normal contact force in between. So for example, if this happened to come up to be about 100 newtons, right, then the only way to get this box to move is to exceed 100 newtons over here, let's say 101 newtons, and then the maximum this guy can give you is 100 newtons, and so you move off with a net force of 1 newton in the direction that you are pushing. Now, once the object moves, no longer does static friction take part, but kinetic or dynamic friction takes over. And so this is the friction that the object moves, or this is the friction that the object experiences when it moves. And this can be a different coefficient. F dynamic is mu d, but also dependent on the normal contact force. Mu d and mu s can be different, depending even for the same surface. Right? Typically, for the same surface, mu d is less than mu s, right? And I think that's something that we can attest to. It's usually easier to keep an object moving than to get it moving in the first place. Right, so here I can push it with a force of 100 newtons. The dynamic friction may be 80 newtons, in which case I would be moving forward with a net force of 20 newtons. Right, so these are the two types of friction, okay, static and dynamic friction. Static friction, remember, opposes the tendency to move. It matches you force for force up to some maximum value. And then once it starts moving, kinetic or dynamic friction takes over.